Hey guys, we got our last day of lectures. So we're gonna finish up our 2-4 chain rule day 2. So let's just dive into our examples. We got 11 today. So first one, we're finding the derivative of y equals sine of 3x. Okay, so following our rules, we should get our y prime equals cosine 3x times 3. Right, so we can just write that as our final answer of, just rearrange it, 3 cosine 3x. Right, simple one. Okay, 2, we have our y prime equals negative sine of 3x minus 2 times 3. So we know that equals negative 3 sine 3x minus, not 3, minus 2. Alright, moving along to 3. And another thing, for some of these tougher ones, it's going to help if you look up look up online some trig derivative worksheets. Okay, some of these, it's going to help. They're out there. So I suggest you guys search that online before you start doing some of these homeworks. There's study sheets out there that exist. So we got 3. So first thing with 3, we want to recognize that this is the same thing. This is the same thing as 1/2 cosine 2x squared, like that. And you can think about it as this is your 2, your 3, your 1. So when we do our prime, y prime, we have our 1 times cosine 2x minus sine 2x, parentheses times 2, which equals negative 2 cosine 2x sine 2x. Okay, and this is where some of that off to the side stuff will help. So sine of 2x we know is equal to 2 sine of x cosine of x. Okay, and you would get that from knowing those conversions. But we know sine 4 of x is 2 sine of x cosine of 2x. So if we have a negative 2 out front, right? If we have that negative 2 out front, we know this can be sine of 4x. Okay, right? Because we have it's the negative 2 cosine of sine x. We have the 2 2's in here, right? And it's negative, so we're doing negative sine of 4x. Okay? For 4 now, when you look at this, we know that, again, we got to kind of do this, think ahead before we start taking the derivative. So I'll just kind of write it down here. We know that negative sine squared of x equals sine of x. Oh, that's negative. Yeah, negative sine of x times sine of x. Okay. This doesn't equal, it's not equal to negative sine of x. Okay. Because when we do this derivative, what you should end up with is negative sine x times cosine of x, and that's it. Okay, some people might want to try to simplify it down and get this right here, but that's not right. Okay, so that's your final answer. You cannot simplify that to negative sine squared of x. All right, hippity hopping down to 5. We got first rewrite this equation. I wrote it cosine of x to the 1/3 plus cosine of x. Notice the parentheses, it's on the outside, to the 1/2. So when we do our chain rule, We got our y prime equals negative sine of x to the 1/3 times 1/3 x to the negative 2/3 plus 1/2 cosine of x to the 1/2 times negative sine, that's a times negative sine of x. Okay, and now from here we're going to make sure we have no negative exponents. So we should have negative sine. We're just flipping everything to the right side. 3x to the 2/3 plus this side, your sine of x stays on top, and your 2 cosine of x to the 1/2 goes to the bottom. And right there is your answer. All right, 6. Let's kind of make a little barrier. With 6, good way to think about this one, right? It's the same thing as just secant squared, right? If it's secant squared, we know that, I'm just going to kind of come down here. Your y prime is going to equal 2 secant x times tan of x. Okay? From there, we should just finish with our tan of x, because we know that's what that converts into. Yep, that's right. And that's your final answer. 2 secant squared of x times tan of x. All right, moving along to number 7. Okay, with number 7, we're going to our y prime right away. We should get secant of x squared, right, times tangent of x squared times 2x. From there, all we're doing is moving that 2x out to the front, right, make it look nice. 2x secant x squared tangent x squared. Come on. There we go. All right. Now we're doing the whole find the equation of the tangent line to the graph at the point. All right, so we got a little bit more work here on 8. So first things first, I just kind of rewrote this up here as 2x squared minus 3 to the 1/2. All right, so I could look at it that way. So then when I do my f prime of x, I get 1/2. 2x squared minus 3 to the negative 1/2 times 4x. Okay, that equals 2x squared minus 3 to the negative 1/2. Okay, which in the end equals 2x over 2x squared minus 3 all up to the 1/2. Okay? So now we got to take our 2 and plug that in to our first derivative. Okay? So we have our f prime of 2, which is going to equal 4 over the square root of 5. All right, so now when we have to put this in our line equation, we have y minus square root of 5 equals 4 square root of 5 x minus 2. It's going to be y minus square root of 5 equals 4 over square root of 5 x minus 8 square root of 5 plus square root of 5. So then your final answer should be y equals 4 square root of 5 x minus 3 square root of 5. Okay. Yep. And that is your final answer. Okay, remember we took the first derivative, we plugged in the x value in that first derivative, and then use that slope, because that result is the slope, to plug it in, get our little line equation. All right, now we're doing the same thing. Okay. So for this first one, we're taking the first derivative, right? Our first derivative. I put negative. First derivative of x is going to be negative sine of 2x times 2. Okay. Now when we do our f prime of our x value, which is pi in this situation, I have negative 2 sine of 2 pi equals 0, right? Because this gives you a 0. That should give you a 0. And that's our slope. So now we just got to plug it into our line equation, and all you should get is y equals 1. Alright? Because that 0 just knocks out everything else on that side. You carry the 1 over, that's all you get. Y equals 1. Alright, not too tough. We're going to move on to 10 and 11, where they're asking us to find the second derivative. The second derivative. Okay, so starting off, let's find our first derivative of 3 times x squared plus 5 all to the third. We should have f prime of x equals 9 of x squared plus 5 squared times 2x, and 18x x squared plus 5 squared. Okay, so that's our first derivative. Now we got to do our second derivative. I'm just going to go up here. So we have our f double prime of x, which should equal 18x times 2 times x squared plus 5 times 2x plus x squared plus 5 squared times 18. Had to squeeze it in there. Just move that equals out. Equals 72x squared plus 5 plus 18 x squared plus 5 all squared. So this is 18 x squared plus 5 4x squared plus x squared plus 5 18 x squared plus 5 5x squared plus 5. And from there, that 5x squared plus 5, you can pull the 5 out, so it's like 5 times x squared plus 1. So it leads us to our final line. X squared plus 5. X squared. Let's make that clean. X squared plus 1. That is your second derivative. Okay, not too bad, not too bad. Now, on to our final one. 11 here. All right, so let's take our first derivative. Remember that this cosine squared of x, it's like saying, it's the same thing as we're saying like cosine of x squared. Okay, that sometimes just helps when we're dealing with derivatives to view it that way, because the notation of trig squares is just weird how they put it before the x. So we got our first derivative. It's going to be 2 times cosine of x times negative sine of x. That's going to take us down to negative 2 cosine x times sine x. Okay. You could also look at it as it's also the same thing as negative sine of 2x, if you know that conversion. But let's do our second derivative now. F double prime of x. we should have negative 2 cosine of x plus 2 sine of x sine of x. Okay, from here, we should have our negative 2 cosine squared of x minus sine squared of x. And then we should get to our final result of negative 2 cosine of 2x. All right. So, like I said before, I suggest you guys a good thing to do, practice, strategy tool. Go out there, find the different trig derivatives, find a sheet that has it all. Use that website if you guys don't remember the website we gave you right before all this stuff went down. It's Paul's Mathematics. All right, just look up Paul's Math Lessons. Okay. Paul's Math Lessons. Okay, go to the website. It has calc. It has everything you could use. I use that site through a bunch of different classes in college, and it's still relevant to this day. So take advantage of that stuff. Let me know if you have questions.